are the explorers. We have a need to find what is out there. It is a drive inside each and every one of us. The drive to wonder, to push the boundaries, and to explore. We expanded across our lands, settling new frontiers. We took to the oceans and learned that we could cross treacherous expanses in the pursuit of discovery. And then we took to the skies and flew. But that wasn't enough. We left the planet and redefined what was possible. We flew in space. We walked in space. What once was a melodramatic flight of fantasy became reality. Then, a new generation of spaceships captured hearts and minds for 3 decades and helped build a castle in the sky that is our lasting home in space. We have always looked up. For centuries, we wondered what was on the other side of the sky, and we have begun to answer that question. We have learned that all the exploration humankind has achieved is only a beginning. Right now, men and women are working on the next steps to go farther than we have ever gone before. New vessels will carry us, and new destinations await us. Everything we have ever accomplished leads to this moment in time, where exploration will now take us to the planets and the stars. Our nearest neighbors in the night sky have beckoned us, invited us, dared us to reach for them. We are the explorers. Throughout our history, we have taken both small steps and giant leaps in that pursuit. Our next destination awaits. We don't know what new discoveries lie ahead, but this is the very reason we must go.
Welcome to the cupola. Ready to play a little music?
Indeed. Your scenery looks a little nicer than ours. Have you got everything you need? Do you have your trusty floating guitar pick with you? Excellent. Mine is subject to gravity. Yeah, I know. Yours matches your mission patch. Gleeks, are you guys ready to do this?
Yeah!
Chris, ready to go?
Yes, Ed, I'm ready.
Okay.
Let's do this.
Let's do it.
On solid fuel wires, turn the key and light the fire. We're leaving Earth today. This rocket's burning bright. We'll soon be out of sight and orbiting in space. Push back in my seat. Look out my window, there goes home. That ball of shiny blue houses everybody anybody ever knew. So sing your song, I'm listening. Out where stars are glistening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I want to get back soon. 18,000 miles an hour, fueled by science and solar power, the ocean's racing past. At 5,000 tons, 90 minutes moon to sun, a bullet can't go half this fast. Floating from my seat, look out my window, there goes home. that brilliant ball of blue is where I'm from and also where I'm going to. So sing your song, I'm listening. Out where stars are glistening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I wanna get back soon. All black and white just fades to gray, where the sun rises 16 times a day. You can't make out borders from up here, just a spinning ball within a tiny atmosphere. Push back in my seat, look out my window, here comes home. What once was fueled by fear now has 15 nations orbiting together here. So sing your song, I'm listening. Out where stars are listening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I wanna get back soon. You know why I wanna get back soon. You know why I wanna get back soon. Yeah, you know why I wanna get back soon. You know why I wanna get back soon.
A half-century since it launched the first American to orbit, NASA has begun a new era of space exploration. With the International Space Station established as a permanent human outpost in low Earth orbit, NASA has embarked on two parallel paths of future spaceflight. Both are complementary, and both are revolutionary. On one path, NASA is fostering American private industry to develop commercially available flights to orbit for cargo and eventually people. On the other path, NASA is focusing its expertise to build new spacecraft and rockets to take America to deep space, farther than we've ever been before. Two pathways to two frontiers. One maintains and expands our foothold in familiar territory. The other extends our reach into the unknown.
Three, two, 1, 0.
From Cape Canaveral Air Force Station in Florida, a commercial rocket roars into the sky. It's the first of a new generation of commercial launch systems. Its flight is made possible largely because, for decades, NASA has opened the borders of space. Whether it's building and launching spacecraft, taking humans to the moon, or making Earth orbit a place for everyday work, NASA's experience is America's experience. The technologies from those achievements helped build our nation's aerospace industry. With those missions, NASA poured the foundation of United States human spaceflight. Now, NASA is partnering with private American companies so they may join the voyage. The International Space Station, the largest, most complex space vehicle ever built, and it has become our permanent home in space. Crews live and work on board, conducting research and experiments to improve life on Earth. Their work is also preparing us for those longer journeys that are ahead. but the station also serves as a catalyst for the evolution of commercial spaceflight. Station crews need regular shipments of food, water, clothing, spare parts, and experiments. That demand creates an opportunity for commercial space companies to augment cargo shipments by NASA's international partners.
I view these vehicles like wagon trains supplying some government-run fort out west. And it doesn't matter whose wagon train it is. What's important is that the wagon train eventually makes it to the fort, and that's the model that I see.
Two companies, Orbital Sciences and SpaceX, are both in the final stages of building and testing new unmanned cargo craft to fly to the station.
So we have to have customers at the end of the day that where we can provide a useful service, and that can also prove out the rocket technology. With every flight, we learn more. Just being able to work in collaboration with NASA is awesome, and that teaches us a lot. So to be a part of that enormous effort is really great.
Other companies, including Blue Origin, Sierra Nevada, United Launch Alliance, ATK, Excalibur Almaz, Boeing, as well as SpaceX, are working to eventually fly crews to the station. It is a new approach to spaceflight. NASA lends its experience, but the companies design, launch, and own the spacecraft.
We didn't talk about how to do it. We didn't say how large the vehicle needed to be, how much propulsion, how much thrust, how much volume there had to be in the particular cargo carrier. The only time we got specific about requirements were the interfaces with the space station, the electrical, the data interfaces, and the safety requirements. Everything else was goal-driven so that the companies can use their innovation and optimize their systems so the best possible system to deliver these supplies to the station.
While commercial partners focus on reaching orbit, NASA is at work on a spacecraft and launch vehicle to explore the solar system. NASA's Space Launch System will be the most versatile and powerful rocket ever built. It will launch crews farther into space than ever before, to an asteroid, back to the moon, or even onto Mars. Sitting atop the Space Launch System is Orion, NASA's new ship to take astronauts on those journeys.
So Orion is really an exploration spacecraft. It's the vehicle that will house the crew when we do those exploration missions. It provides the life support, the power, stowage for their food. It also then provides the propulsion and the other systems that allow us to go to those far-reaching, distant places.
Work is well underway on Orion. Hardware is being built from coast to coast. Testing, checks, and reviews all march toward a first unmanned test flight in 2014. Orion will fly 10 times farther from the Earth than the space station. It will return to Earth at speeds not experienced since the Apollo missions to the Moon. Orion also benefits commercial partners. As NASA creates and tests Orion hardware, the lessons from parachute tests, heat shield development, and aerodynamic studies are shared. The collaboration prevents duplication and speeds development. The programs mature together and ultimately rely on each other for success.
We want to stimulate the commercial space industry in America. That is part of NASA's charter. We have seen great progress with the companies. There's a tremendous amount of talent and knowledge and experience out there.
The commercial systems allow us to do the space station mission cheaper, so we can enable doing the stuff we've never done before.
seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Shadow. 4 forward, drift into the right a little. 30 seconds forward, drift. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
That's one small step for man. One giant leap for mankind. Oh, that looks beautiful, Neil. It has a stark beauty all its own. It's like much of the high desert of United States. It's different, but it's very pretty out here. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation.
Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.
Roger, understand. We're number 1 on the runway. 7, 6, 5, engine arm ascent. Beautiful. Very smooth. Very quiet ride.
Apollo 11, this is Hornet, over.
Apollo 1, this is Apollo 11, reach your light course, our position 1330.
Got a package full of wishes, a time machine, a magic wand, a globe made out of gold. No instructions or commandments, laws of gravity or indecisions to uphold. Printed on the box I see, Acme's built a world to be. Take a chance, grab a piece, help me to believe it. What kind of world do you want? Think anything. Let's start at the start, build a masterpiece. Be careful what you wish for. History starts now. There be people or peoples, money, funny pedestals for fools who never pay. Raise your army, choose your steeple. Don't be shy, the satellites can look the other way. Lose the earthquakes, keep the faults, fill the oceans without the salt. Let every man own his own hand. Can you dig it, baby? What kind of world do you want? Think anything. Let's start at the start, build a masterpiece. Be careful what you wish for. History starts now. Sunlight's on the bridge, sunlight's on the way. Tomorrow's calling, there's more to this than love. What kind of world do you want? What kind of world do you want? What now?
Hello, this is Scott Manley, and I'd like to talk you through this video I created showing the rate of discovery of asteroids for the last 30 years or so, starting in 1980. Now, what you see here is a top-down view of the inner solar system with 4 planets in the middle, and on the edges you can see Jupiter. What you also see is a large number of green, yellow, and red spots denoting the position of asteroids. The colouring is primarily to indicate how close they can come to the Earth. Green are main belt asteroids, yellow cross the orbit of Mars, and red cross the orbit of Earth. Also, as asteroids are discovered, we flash them white to make them more obvious. Now, if you look in the bottom left, there are 2 numbers. The first is the year, and the second is the number of asteroids known on that date. Now, you can see this number grows as more objects were discovered by astronomers. In addition, the highlighting of the discovery location lets you see patterns in the discovery process. The most obvious pattern is that most objects are being discovered opposite to the direction of the Sun. And this, of course, makes total sense, since you're going to be looking for these things in nighttime skies. Sometimes you see a big flash of discoveries lined up with another planet. Scientists were perhaps looking for new moons around these planets, but found asteroids as well. In the 1980s, most imaging is being done with photographic plates, but by the time the mid-90s roll around, electronic imaging becomes the standard. This gives a significant increase to the discovery rates, since the turnaround time for image processing and analysis gets much faster. When you're trying to discover objects moving across the night sky, it's very important that you follow up on the observations before the object moves too far and is lost. Now, by the late 90s, a number of dedicated asteroid discovery programs are in full flow. These combine electronic imaging with automated image processing and follow-up. Hundreds of new objects are being discovered every day, and new patterns of discovery become evident. If you watch, you can see the discovery rate pulsing roughly twice a second. This corresponds to the lunar cycle. During a full moon, it is harder to discover faint objects since the moonlight makes the background sky brighter. There's also a sparse dead spot around the 5 o'clock position. Apparently this corresponds to the cloudy season in Arizona, where a number of these automated surveys are based. Now, by mid-2000, we're starting to see hundreds of thousands of known objects, and it's getting very crowded in the inner solar system. But you need to appreciate the distances here are huge. 1 pixel at the highest resolution is still 500,000 kilometers. So all those objects apparently buzzing the Earth are still a long way out. And now for a few seconds you're going to see the discovery pattern of WISE, the Wide Field Infrared Survey Explorer. That was a space telescope designed to image the entire sky in infrared. And so we're almost up to the present day, and we have over 500,000 asteroids in our database. I'm Scott Manley, thanks for watching.
balra 20 fokkal. Vidd balra 20 fokkal.